Presentation, right?
Just a minute, ma'am. Just a minute.
Yeah.
Yeah. Uh, I will first introduce you and then we will start.
Okay. Okay.
Uh, Very good morning to all. I am Dr. Yogesh Gajmal, Associate Professor, Department of Information Technology, FAMT Ratnagiri. Welcome all for the expert session on machine learning, current trends and prospects. Here with us today is the great personality Dr. Jaya Vrinda ma'am. It takes immense pleasure to introduce a speaker of the day. Ma'am is working as a professor and chairperson in Artificial Intelligence and Machine Learning Department in Dayananda Sagar University, Bangalore. On the behalf of IT department, welcome you ma'am for today's session. Over to you ma'am. Thank you.
Okay. Thank you so much, sir. First of all, I thank Dr. Vivek and Dr. Vinayak. He was my classmate. I am a classmate for arranging this talk. So I'll start. Sir, is it like in between any doubts they'll ask or end of the session? What is the plan? Hello? Hello? Hello?
Hello.
Yeah. Shall I start, sir?
Ma'am, are you presenting screen?
Yeah, 1 second.
Yeah ma'am, please start. Yes
Okay.
ma'am, please start.
Yeah, yeah. Are you able to see the screen, sir? Hello?
Ma'am, there is
Sir,
the
are you
option
able
to
to see
present.
the screen?
No ma'am.
No. Okay.
Ma'am, below there is a present button is there. Please.
Yeah. Yes, sir, I'm selecting that. Now, are you able to see?
Not yet ma'am.
Okay. Present. Now, I, I think it's uploading.
Uh, no ma'am, not yet. Screen is not visible ma'am.
Yeah, it's uploading, sir.
Okay,
It's
under
taking
process.
time.
Okay.
Yeah, processing. Now, sir? Yeah.
Yes
Okay.
ma'am. Yes ma'am. Now it's
Okay. Yeah. So today we will be talking about what is machine learning, current trends, and what are the future prospects about machine learning. We are going to discuss today. My slides are moving now. Okay. We will talk about introduction to machine learning, categories, and core methods and applications, insight from our work, emerging trends, and I hope my slides are moving. Hello?
yes ma'am.
Yeah,
Slides are visible.
visible. Okay, fine. Yeah. So let us see what is machine learning. Already, most of the, especially engineering students, you should know. I hope you are aware of this term machine learning. There are n number of definitions for machine learning. Some of the important definitions I have highlighted here. Machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. So basically, it is like we have to first of all train the machine with some data. With that data, machine will learn, and with the machine's experience, it will do some task. That is the idea. So we know it's nothing but it's part of artificial intelligence, machine learning, deep learning, all are part of artificial intelligence. It's like how to impart artificial intelligence to a machine is by using machine learning algorithm. It's not exactly, but that way you can remember these are some algorithms or models which are used to impart artificial intelligence to the machine. Or we can say that machine learning algorithms build a model based on sample data. Your data can be text, audio, image, and videos, or it can either be a numerical numbers as well. So this data is known as training data. Training means we are training the machine to learn. That is why this is called training data. So in order to make prediction or decision, we need some data, past data, which is used to train the model so that the machine will learn with the past data, which is called training data. Or we can also call, suppose most of the cases, suppose we are applying this model for a real-time application, we can call it as a computer is set to learn from experience E with some class of task T and a performance measure P. If its performance at a task in T as measured by P improves E. That is the idea behind what is machine learning. So let us see what is the history of machine learning, when this term machine learning was coined, and what all further developments have happened in this area. In 1950, actually, the term machine learning was coined, and later in 1960, first neural networks applied to real-world problems. Okay, and this is actually happened in a conference which has been carried out in MIT. That time there were a discussion about how to impart the artificial intelligence to a machine, all those things which all happened in this years like 1960s onwards. So 1970, the backpropagation algorithm, which we are using to train the model, I won't be talking much about that, but it is an important algorithm when you learn about neural network, deep learning, etc. And also, one of the neural network or deep learning model is called convolutional neural network. This is widely used by many students and other industries to develop deep learning models. We call it as convolutional neural network. That is actually introduced in 1970, very early, before your birth. Okay. Then 1980s, machine learning and artificial intelligence took separate paths. Like many algorithms have been introduced, and actually we all know machine learning is part of AI, even deep learning also. So all these algorithms and a detailed study started from 1980s, and in 1990 boosting algorithms to reduce bias. Bias is nothing but the error. So what is mean by error, what is mean by bias, I'll be discussing in the coming following. And in 2000, the deep learning concept has come out. 2000. Actually, 2000, the deep learning means from name itself, we know learning in deep. So when you want to learn a topic in detail, what normally you used to do, We will refer a lot of books, we'll watch so many YouTube videos. Same way, deep learning means we will use a lot of data to train the machine or to teach the machine, we can say. So when we need lot of data, definitely our CPU cannot hold all this data. It will be like we have to go for definitely we need a GPU, graphical processing unit. It can only hold all the data. So especially the deep learning computers come when we process images and videos. In 2017, machine learning models in production started. Means industries are started working on machine learning models. And 2019 onwards, well-financed startup leveraged machine learning started. And later on, lot of studies have been happened after 2019 till now. We all know. N number of startups are working in the machine learning area, as well as many companies like IBM, Infosys, all are working. Wherever you find in an industry, one department will be AI. And always there is a very good scope for AI development and data scientist. That is the booming area and high pay. High pay is salary. Now let us see in detail what is meant by machine learning or how do we train the machine. So it starts from the part of feature extraction and training. Assume that you want to train the machine to just identify different type of actions. This is a simple example I have to get a clear idea about what is exactly happening. So what you used to do, uh, first of all, we have to feed lot of images of apples, different type of apples to the machine, and the model will learn. So it is like you can think suppose you are studying in LKG or UKG or first standard, whatever it is. Your teacher is telling this is an apple. Okay? Same way we are teaching the machine also. Like this is an apple, its color is red, its color is blue or yellow, or it is round in shape. This is a fruit. Same way we have to teach the machine. But thing is that when you feed an image of an apple to the machine, how does a machine will understand whether it is a red color apple or whether it is round in shape or whether it's a fruit? So these all things are called features. So you can see here, I have highlighted here what are the features. Okay. So same way how a teacher is teaching the students, same way we had to teach the machine as well. Like this. So for this first apple, its color is red. It is a fruit. It's what is the shape of this fruit, etc. We had to explain. So once you extract these features, it will be in an Excel CSV file we call. In that, this will be arranged like this with the tables. Tables like color, what is the type, and what is the shape. Whether it's a fruit or whether it is a logo, what is the shape of an apple, what is the color. So for extracting these features, n number of techniques are used. We call principal component analysis, linear discriminant analysis, completely mathematics. Okay. So we cannot teach a machine by simply saying these words. Everything will be based on the numbers and some models, some mathematical equations. So some mathematical equations, which is called principal component analysis, linear discriminant analysis. So like that, n number of methods are used to extract the features, and you will be creating a CSV file like this. So once this is ready, we will be training the machine. That is called training data set and extracted features. So you will have the training data set as I told. It can be a text data, numerical data, images or videos. From that, you will be extracting the features or most of the website, these features are available like Kaggle, MNSDI, like that n number of websites are there. There already this data set in the CSV format is available that you will be processing. So this is the workflow of a machine learning model. Suppose if someone tell you to explain with a block diagram or flow chart, you can use this. This is the flow chart, we can say. So you will have the training data, as I told, it can be in images, videos, or text data or numerical numbers. From that, we are extracting the features. Here we call it as feature vectors. Feature vectors. So what are the feature vectors for the case which we have explained? We will have color of the apple, shape of the apple, all these are the feature vectors you are extracting. Okay. So training data set will be the images of different type of apples. So we can also have labeled data or unlabeled data. We'll be discussing in detail about this. Then we will give this to a machine learning algorithm model. Then once we are training the machine and saying that it's the machine is ready. It's like the teacher is teaching the students, this is an apple, this is red in color, this is round shape. Then whenever the student who sees an apple, he can identify, oh, this is an apple. It may not be the same apple or picture which teacher has already taught in the class. It can be another apple, but student can identify. That is why you can see this is happening in testing time. We can call it as testing time. We here you can see the new document or new data which will be fed, and for that new data again features will be extracted and the model will predict it's an apple. It's red in color. So this is what the idea behind the workflow of machine learning. Next, we have categories of machine learning. You might be heard about this. Otherwise, let us see what is this. Different type of learning methods are there. As I told, supervised learning means it is labeled data. Also, you have a supervisor to teach. Like assume that, as I told, a teacher is teaching the student saying that this is an apple, this is a cat, this is a dog, like that. So teacher he or she will be labeling it. Labeling means just putting the name. Same way, we will be feeding the machine and saying, okay, I'm feeding this. This is an apple. Okay, this is an apple. You can extract the features and identify whether it's a red color apple or is it a fruit, is it a logo, etc. So somebody is there to guide. There is a supervisor. So learning is very easy. Someone is there to guide you. In unsupervised learning, what is happening? There is no teacher at all. I am giving you a book and I am telling, oh, this is the book for machine learning. You go to library or somewhere, you learn yourself. Okay. Then how do you do? You will be learning each chapter. You will find out the important points. There, there you have to do labeling or clustering. Okay, these are coming in this group. These are coming in this group. These are the important points. All those work, one work extra I am giving you because no supervisor or no teacher to teach you. That is what is called unsupervised learning. We will see some examples. You will get some good idea about supervised and unsupervised learning. Now, reinforcement learning means you can think about a robot or game. When you play games in a mobile or wherever it is completely controlled by reinforcement learning. Means completely learning from experience. Okay, so when you play more and more games, like suppose you have started playing cricket, after playing some 2 to 3 months continuously, you learn a lot, and you will you can score more, right? Same way it is like that. Even robot is an example for robotic applications are examples for reinforcement learning. By experience it learns, or by seeing the environment the agent will learn. So that is reinforcement learning. Now let us see supervised learning in detail. Here you can see letter A, letter B, both are labeled data. Already I am saying the machine, this is letter A, this is letter B. Like this I am training, but this is a typed letter. But when you go for handwritten letter, it's very complicated. Even myself, if I write a letter A in the morning, at 9 o'clock, and afternoon or evening when I'm very tired and writing it will be different. We can say orientation is different, pattern can be different. All person can write in different ways. So assume that we have millions of people in the world and you are training a machine to classify different letters, then it's really difficult, sir. So most of the cases we use a linear regression, neighbors, hidden Markov model, K nearest neighbors, decision tree, random forest, etc. Those who have already done machine learning, they might be learn about this in detail. I'll not be going in detail about this. These are the supervised learning models we are using to classify. So here you can see we have two classes or two categories, category A and category B. So this is called classification. Normally in supervised learning, we have classification and regression methods are used. So based on that, we will be applying any one of this model which I have listed. So always you can remember this picture when we talk about supervised learning methods. Next, let us move to unsupervised learning. In unsupervised learning, you can see here the number one itself we can write in different ways, like this, and then we will be doing clustering. Clustering means the pattern which is belonging to this type of one will be in one cluster, another type of one in another cluster. K-mean clustering is one of the very best model used for very simple and best model used in unsupervised learning. Another is Gaussian mixture model, principal component analysis, etc. Are the unsupervised learning models. In reinforcement learning, as I told, most of the real-time application we can use reinforcement learning, even supervised and unsupervised as well. So here, physical world in which the agent operates and current situation of the agent is called the state, and the feedback from the environment. So what is the feedback we are getting from the environment? Based on that, the model will learn and it will improve because as I told, the score will improve as and when you play more and more games. This is one of the example for reinforcement learning. You can see most of the games we will be applying reinforcement learning methods. Now, applications of machine learning is not possible to list at all because several domain-specific areas are also emerging. Any cases where you want to automate you want to apply automation, we can go for machine learning. These are some of the important areas like healthcare, education, financial modeling, computer vision, speech recognition, NLP, natural language processing, robot control, etc. are the emerging areas of machine learning areas applications. As I told, we can apply machine learning in any area where we need automation. Core methods and applications. The most widely used machine learning methods are supervised learning methods. As I told, it's very easy because already we are feeding labeled data and there is a supervisor to teach the machine. And it's one of today's most rapidly growing technical fields, we all know. It is because of the statistics and data, allow huge data available. That's a thing. When computer has been introduced, we have a huge data set. How to make use of this data set, like that, the idea AI and data science, all those ideas we developed. So, if you talk about recent progress in machine learning, has been driven both by the development of new learning algorithms and theory, and by the availability of online and low-cost computations. And data revolution has been enhancing machine learning. We all know this. Availability of data, huge number of data, which has helped to introduce the concept of AI. Actually, machine learning has progressed dramatically over the past 2 decades. We all know wherever we go, we can hear this word, and many automations are happening. A few important areas has progressed in the past 2 decades. One is medical diagnosis, very helpful for the doctors to predict. The model can definitely support the doctors, like for examples like COVID time. COVID time, the X-ray of a COVID patient and another disease almost look similar. So for a radiologist, it's very difficult to identify whether it is COVID or any other disease. So such cases, the machine can give an accurate prediction. And in many other cases also identifying the tumor cells in an MRI scanned image, etc. It can give an accurate result. Another area coming up is called audio and speech recognition, which is called machine hearing. Another is object face and facial expression recognition, like to detect a criminal or to identify the facial expressions, emotions of the patient, people, etc. And number of applications are there in this area. These are the coming up and going on researches are happening in these three areas. So the facial expression recognition, many students, those who have already done machine learning, might be done face recognition, etc. So it's not a very easy task because we know codes are available everywhere, ChatGPT, GitHub, everywhere. But when you go in detail and if you develop your own code, it's not an easy task. When you for the face recognition itself, if it is not the front view of a person or side view, or if you are detecting the criminal face, suppose the criminal is traveling in a vehicle, how to track the vehicle and how to take the pictures, and there will be so many occlusion, many parameters will affect, then how to extract the features and identify the face. It's not an easy task at all. So these are the step-by-step process for facial expression recognition. First of all, definitely we need an image with the face of a person. Then we have to localize. Okay, so definitely facial expression means, suppose you want to identify the expression of a person, whether the person is smiling, crying, etc. The important part is, we all know, the mouth and eyes. By seeing the mouth, whether teeth are visible, or by seeing the eyes and teeth, we can identify whether the person is happy or sad, etc. So what is required? Actually, we can extract only the mouth part and the eye, and from that machine we can teach a machine. That is what is called face localization. Then we will extract these features and we can use any classification models. Here you can see class 1, class 2. Class 1 means it will be like, sorry, class 1 can be happy face, class 2 can be the sad face. Like that you can classify. If you have two classes, you can have more than two classes also possible. So these are the blocks we have explained: face localization, tracking, feature extraction, and classification. These are the things used in facial expression recognition. information. And in this important as a research challenge is to extract features only from the informative region of a face. So there are n number of challenges. As I said, when we feel like, oh, recognizing a face is very easy, or detecting or the emotion detection all are very easy. But there are a number of challenges like face localization and tracking is not easy. Suppose you are capturing a person's face when a vehicle is moving, or any other object which we call occlusion is hiding the face, or if it is a side view of a person, all those things will affect. Then feature extraction is challenging, recognition of non-basic expressions, multi-view or view invariant FER. You can see such cases, it's really challenging. Actually, this area with the dots we call is the region of interest. Region of interest means ROI. ROI means the region which is very important for the detection of the face, like mouth, also the mouth and eyes. Mouth and eyes are the important. So if it is covered due to some occlusion, or if the picture resolution is very not clear, low resolution images, etc., are the challenging thing. Or suppose such cases, how do we find out which are the happy faces? Almost all look similar, or only the side view of a person, or the person is wearing a cooling glass, etc., etc., are very challenging. Whether person is smiling, happy, sad, or crying, etc., are challenging. One second. My battery is low.
Hello, ma'am. Are you there? Hello? Hello? Ma'am, am I audible? Hello? Ma'am, am I audible? Hello? Hello, ma'am? By that time, we see.
Hello. Sir, are you able to see my slides?
Yes, ma'am. Please
Hello.
continue.
Yeah.
Yes, ma'am. Continue.
Yeah. I'm sorry. It's some internet issue. Okay. Okay. So let us continue. We have reached about medical image diagnosis, medical image analysis. There are a number of challenges in medical image diagnosis as well. But we call one is low quality image. Suppose if you are capturing an MRI or whatever it is, so some part of the uh, images or body will be blocked with blood vessels, all those things. So we will not be able to capture the exact image. Another issue in MRI image or scanned images, whatever part you are seeing here, the volume of the uh, sorry volume of the tumor cells. Suppose if it is in the MRI image is it about 20 millimeter, actual size may be bigger than that or smaller than that. There is a possibility. So these are the challenges we will be facing, which is called partial body map in during image acquisition itself problems if it is a low quality images, and after getting the MRI we are training the machine. Also, there will be noises and other things. These all things are the challenges we are going to face. So I have published around 15 to 20 papers in machine learning area. Some of the important papers I have highlighted here. One is machine learning based COVID-19 cough classification. This work we have done during the COVID time. And another paper, image description for the visualization. So for this COVID-19 tough classification, we have published some two papers in this area, one in IEEE Explore and another in another panel. So we have collected data from Cambridge University. They have shared around 104 video signals. Means it's like a speech spectrum uh, with actually around COVID 54 were that of COVID-19 patients, COVID samples, and 50 were that of healthy individuals. So this cup audios was already sampled at 44 kilohertz frequency, and this is the method that used. We have extracted the features, then we have applied some models and classified whether it is a COVID cup or not. So actually, we have extracted around 65 features. They are extracted, and some of the important features I have listed here. One is zero crossing rate, root mean square, energy, power spectral density. These are the MFCC mel frequency, uh, then dominant frequency, plus factor, spectral bandwidth, plus spectral. So this is just to get an idea how to start to implement a machine learning project. That's why I have taken this example. This is completely the cuff signal based COVID cuff signal. So this is what we have done. We have find out what is the zero crossing rate for a normal patient and healthy cuff and COVID-19. Your cuff signal will be like this spectrum. Wherever it crosses the 0 point, it is called zero crossing. Zero crossing. Also, power spectral density we have calculated. Power spectral density of the spectrum COVID signal. Another feature we have find the dominant frequency. So you can see the dominant frequency of a healthy person, sorry, healthy person, varies from around 250 to 420, and for a sorry, COVID patient varies from 250 to around 420. But healthy person, you can see here in the second diagram, it's around 250 to more than 450. And also we have used some three others SVM logistic regression and random forest. And we have also done an analysis based on number of features. So it is not necessary if you go for more number of features to get a better accuracy. Here you can see an example here. For 25 features, logistic regression is giving only 76% accuracy prediction, but 15 features logistic regression is giving 17%. This is what we call overfitting. Overfitting means we accommodate more number of features, but the mathematical model will be complicated. So the machine will not predict properly. That's why the accuracy of prediction is suppressed. It's not necessary always. We have to go for more number of features to get a better accuracy. This is another project we have done. This is basically for visually impaired people. All are enjoying social medias like WhatsApp, Facebook, etc. Think about visually impaired people. They are also really interested to enjoy all the social medias. We have millions of visually impaired people in the world. So here it is. We have trained a machine with around 1 lakh of images because any type of images will be there. So this is the predicted caption. You can see two red flowers, a large leaf stem, and some leaves. So actually here in each one you can see only one red flower is there. So actual caption is red flower with leaf stem and leaves. So these are another application we have developed. Now let us move to emerging trends and prospects. So what are the emerging trends in machine learning? We all know 77% of devices presently uses machine, like Netflix, Alexa of Amazon. global warm, and many industries are working on this area. Even in finance, also we call fintech. All areas are coming, and automation areas in business, etc. And forecasting of like climate forecasting, prediction, all those things, stock market prediction, then faster computing, etc. Are the emerging areas where we can use machine learning. So this is we all know Gartner is one of the top ranking consultancy firm. This is what they have predicted about machine learning, what is coming up AI. This is 2021 Gartner's hype cycle report. Next, coming years, 2 to 5 years, what are the areas coming up? You can see with the blue dot here. Composite AI is coming up. Responsible AI all are coming up in next 5 to 10 years. Edge AI, all these things, AI and cloud services, deep learning. Already it's in progress. Natural language processing, machine learning, even AI for quantum computing applications, etc. are they coming up. Another coming up trends is in IT industries related and other domain related, like ML and IoT. Because definitely when we want to process the data, real-time application, we will be using n number of sensors. Camera is also a sensor. Suppose if you want to monitor activities in a mall or airport, etc., you will be using CCTV camera. Or suppose for agricultural applications, you can use this temperature sensors, all those sensors, which can be used in the data, kinds of data we can get from IoT devices and we can process. Another ML in cybersecurity. We can forecast any alert. We can forecast and send an alert in the future. Or within 1 hour, there will be a cyber alert for cybersecurity applications. And another interesting thing is long-form machine learning. In this, it is like we can drag and drop the blocks. Data set can be drag and drop. Also, different models. So this is basically targeted to the people, those who doesn't want to do the coding, or it is not necessary to know about the models and coding. So simply you can drag the data set and you can use many n number of models which will give you different accuracy of prediction for different models. Accordingly, you can decide which model is the best model for a particular. Another thing is tiny ML. So like smaller programs on IoT edge devices can achieve lower latency, lower bandwidth, lower power, and better privacy. So applications like the predictive maintenance of industrial centers, IoT project on solar cell systems, or etc. Small scale type of thing. If you want to apply tiny values. Auto ML is almost like normal ML. There is no code. We will be drag and drop and decide what is the which model is the best. So it is like the solutions aim to bridge the gap as it does not really rely on any ML experts. So anyone can use. Coding skill is not at all. Next is MLOPs are used in business applications. So novel way of improving the way that machine learning solutions are developed to make them more useful for business applications. Next is full stack deep learning. Like suppose you have developed a model and we are using GitHub like that place to upload our project. Suppose you want to make your own like whatever it is. In that, you can upload whatever model you are using. It will be like an open source, full stack design projects. So the other people in the world can use your code and process. Another thing is very interesting area today is generative adversarial. This has been introduced in a paper in 2014 by by uh, Langwood fellow, and this is also called DZCAD, Deep Correlational General Adverse Network. So, what is the interesting thing of this is that uh, it is like one thing interesting thing of GAN. It can generate images which almost look like a real image. Real image. For that, we will train the model with the real image as well as the fake image, and the model has to identify whether it is real or fake. That is called generative adversarial networks. So training data will into real samples of the discriminator, and generator network will generate the sample from the random noise of examples and move to the discriminator network. And the discriminator will check whether the samples are from the real or generator or fake image. So this is the steps to train the GAN. As I said, we will be training the GAN with the fake input as well as real input. So whenever you train a machine for any applications, we will go for the worst case. Like suppose your teacher is teaching you all different type of possible problems in a particular area, all the worst type of or challenging problems, then you will be able to write the exam with any type of question you will be able to answer. Same way, here we have to train the machine with all the cases, all the worst cases also, so that the machine will be very smart enough to perform that task. That is the idea. So I'll show you some pictures generated by the neural network, generative adversarial neural network of some bedroom pictures. So it is like if you give some text messages saying that a bedroom with a bed, a table lamp, all those things, the machine will generate the images. Or it's also like if I tell a story to the machine will create an images or video for the story. This is the very important thing coming up, and a lot of people are working in this area. You can also generate the data set by using GAN. It almost look like a real picture. These are the applications of GANs. Prediction of next frame in a video, text to image generation, also enhancing the resolution of an image, interactive image generation. Emerging trends in machine learning, unsupervised learning, and reinforcement learning. So far, most of the cases we are using. One second. My slides are moving, sir. Hello. I hope you are able to see.
Hello, ma'am. Now
My
you are on
slides
which slide you are
not
now?
moving.
Sorry, ma'am. You are on which slide?
I am on emerging trends in machine learning, unsupervised and reinforcement learning.
Slide number, ma'am. Slide number.
Number 49, sir.
Slides are not moving actually, ma'am. I
Yeah.
am moving that actually.
You are able to move?
I am moving accordingly, but if possible for you, then you can.
Now I think you can keep here. Yeah, fine, fine.
Yes.
Oh, okay. Uh,
Now you are on
previous,
49.
this is 50, sir. Can you move to
Yeah. Okay.
49, sir? I
Yes. Yes.
think yeah. I can also move, I think. Shall I move, sir? Is it visible? Let me check.
Yes, ma'am. Do it.
Okay, okay. So these are the another emerging trend which is called few shot, one shot, and zero shot learning. This is completely based on the size of the data set. In few shot means limited data only. In applications in like image classification, facial recognition, and text classification, we need not have a huge data set. May not be required for some cases. Such cases we can use few shot, and one shot learning means uses much less data. Examples like comparing ID photo of the image of a person through a camera, like passport office or wherever. It's a one-shot learning is enough. Very less data set is required. Zero-shot learning means like suppose we can think about the learning without data also. Without data also, like suppose sir, can you move to next slide, sir? I'm not able to move. Hello? Yeah. No, just the previous. Yeah. Next. 51, sir. I don't know why. Okay. It's moving to 52. Okay. Zero shot means it's like there is machine will learn with a lot of data initially. With that experience, it can work for a related data set. Is possible without any training. That is called zero shot. We know many more machine learning areas are coming up in 2023, and obviously areas like finance, cybersecurity, quantum computing, and even healthcare is growing up areas. A lot of algorithm can be applied in this area in future. So this is what the conclusion, and you can move to references. Hello, hello.
Yes, ma'am.
Yeah. Okay. So any questions? Yeah, sir.
Uh, yes, any questions? No question, ma'am.
Okay. Okay. Then thank you so much. I hope no questions means there are two possibilities. The audience has not understood anything, or everything is clear.
Everything is clear, ma'am. So,
Okay.
thank you, ma'am,
Yeah.
for such a informative session as well as for your time. Thank you very much.
Okay. Sorry, sir, because of internet issues, some
No issue,
issue
ma'am.
was there. Yeah,
Mistakes
I
are
had some
happening.
health issue and I am on leave. Yeah.
Yeah.
Okay. But any students or faculties those who are interested to work with us, definitely, yeah, we can do some collaboration project also. We are doing a lot of research along with ISRO, DRDO, etc. in machine learning and deep learning areas.
Yeah, sure, ma'am. Yeah,
Okay.
sure.
Okay.
Thank you so much,
Thank you,
ma'am, once
sir.
again.
Yeah, thank you so much.
Okay.